Okay, so we're going to look at phase diagrams today. So let's get started. A phase diagram is going to be a graph that's representing the phase or state of a substance at any given temperature and pressure. Now, every substance is going to have its very own unique phase difference. They're all going to be slightly different. So let's look at some of these points here. So we have here a generic phase diagram. So we are increasing collisions as we increase that pressure coming up that vertical axis. We are adding energy as we are going across that horizontal axis. So when we look at this, the solid lines that are on the graph are going to represent the temperatures and pressures at which changes in the phase occur. That means that both of the phases are present along that line. The spaces that are between the solid lines are going to represent the temperatures and pressures where there's only one phase of matter present. So over here we are dealing with solids. Here we have liquids, and here we have gas. So when we are adding energy, the solid is going to convert to liquid and then vaporize into gas. Or we could add energy and just go straight from solid to gas using a process that is known as sublimation. If we are releasing energy, the gas is going to condense to a liquid and then freeze to a solid. The other option we have is to go from a gas straight to a solid in a process known as deposition. Well, we want to look at our freezing points and our boiling points, our critical points on this graph. We're going to start with the normal freezing point at standard pressure, 1 atmosphere. This pressure line, where it crosses the transition from solid to liquid, that is the point where we transition. So this point right here, standard pressure, that tells us the temperature we would transition from freezing to liquid, from liquid to freezing. So if we are freezing, we are going to be removing energy from the system. If we are melting, we are going to be adding energy into the system. If we continue along that standard pressure line to our normal boiling point, that's the temperature down here that results in that transition between liquid and a gas. So that means when we're boiling, we're adding energy, and when we're condensing, we're taking energy out of the system. Another key point in this graph is what we call the critical point. The critical point is up here at the end of the line of transition between the liquid and the gas. At this pressure and temperature and beyond, the liquid and gas phases are indistinguishable. So we have this critical pressure line. It's going across here. That corresponds to the end here. So at this point, what we have is what's called a supercritical fluid. We cannot tell if it's liquid or if it's gas. It's a supercritical fluid. Probably one of what I think is the most important here is the point at where these lines cross, and that's called the triple point. That means all three phases of matter exist at the exact same time at that very specific pressure and temperature. That is our triple point. So let's give this a try. We're going to try reading one. So here I have a phase graph. If I look at the standard temperature at 0, Pressure at 1 atmosphere. So standard temperature is 0 degrees Celsius, 1 atmosphere. Our normal freezing point at 1 atmosphere is going to be right here. So we're going to be at about 50 degrees Celsius. Our normal boiling point, following that line all the way across, we are looking at about 530 degrees Celsius. Our critical point, this point way up here at the end of that line, that's going to occur at about 850 degrees Celsius, which also occurs at about 1.75 atmospheres. Now our triple point, the point at which everybody crosses, we're looking at about 120 degrees Celsius and 0.4 approximately atmospheres. Okay, so here is another situation. Now ask yourself, what is the normal melting point of this substance? So what do we have? We're looking at the 1 atmosphere. It's going to be the same as the freezing point, so it's going to be 50 degrees Celsius, 1 atmosphere. So we're going to look at the conditions we have here and determine the phase of the matter. So at 0 degrees Celsius and 2 atmospheres, our phase, we are right here. So that is in here at point A, that is a liquid. That is a liquid. If I have a temperature of negative 100 and 0.75, point B here, that is going to be a solid. 400 degrees Celsius, 0.75. That is both liquid and gas. We are right on that line. At 700, 1 atmosphere, we are in the gas range. And at negative 200, 0.25, we are straight in the solid range. So let's look at some more questions we could ask about this diagram. So at point A, what is happening if I reduce the pressure? So I'm coming down vertically to 0.5. What happens? Well, as I come down this line, we go from liquid to solid. We freeze it, right? At point B, if we increase the temperature to 500, I'm going from solid to liquid to gas. So I've got 2 phase changes, solid to liquid to gas. So not only am I melting, I'm also evaporating. At point C, if we reduce the temperature, if I slide it this way horizontally to 300, we are going to condense. We're going to go from that gas-liquid mix to just straight liquid. At D, what happens if we increase our pressure? If I increase my pressure to 1.5, I am going from gas and I am going to condense into a liquid. If I start at E and I increase my temperature to 200, I'm going straight from a solid to a gas, so we've got sublimation happening. So we're going to take a little bit of time, work on your diagrams for your phase, and then we are going to come back for the next video.